Now we're going to look at these keypad things. They're quite often called matrix keypads. This one is a 4x3 one. The type we're going to play around with is one of these, just like that, but same deal. The way it works is basically a 4x4. It's got 16 buttons. However, there are only 8 pins on it. Now this one's got 10, but you ignore the furthest left and the furthest right. And how does it work? Well, basically, instead of having 8 inputs, we've got actually 4 inputs and 4 outputs. Now, if you send a little electronic signal out here on this one, and then check all 4 of these inputs, whichever one is pressed, you can say, okay, well, that is pressed. And then it basically goes through each of those combinations and checks which one is pressed on the inputs. There's an example one on Circuit Wizard here. However, I'm not going to cover this code. It is actually a neater way of doing it with this table. However, I think starting off, we're going to just look at a slightly longer winded way, which is simpler. So let's look at a 4x4. Now bear in mind it is that much bigger. We've got an extra row or column here. So we're going to have a lot more variables to look at. Now I'm also using a Genie 20, which is one of the rarer project boards in our stock. The reason is I've covered things like LCDs, and further down the line we play around with a servo on the 3 output pins, a signal output. There's a signal output Q0 down here, which is good for a servo. So it bypasses this transistor chip that amplifies it for LED signal voltages. Now it doesn't work if you use this transistor chip. You want the unamplified output voltage, which is available on this Genie 20 here. All 8 outputs have their own unamplified outputs. So it's just a little signal voltage that comes out of this Genie. And that's ideal for this. So we've got these 4 here. Sorry, let me just try and scroll properly. So these 4 here go into these 4, and then these 4 come into the inputs. So if you imagine back here where we're looking at inputs and outputs, we've got this configuration here. And this, I think this will be the easiest way to get your head around it if you look at this flowchart. So it is bigger, bearing in mind we've got an extra column, but it's not quite as neat as compact as using the table method in the example file. Those of you slightly more advanced might be able to get your head around the table thing and figure it out yourself, but this I think will be straightforward. So if we send an output to Q0 first of all, and then we check the 4 inputs corresponding, so we can say, let's just do it in debug mode and see if we can figure it out. So just press play. Well, so yeah, it's going slow enough to see what's happening. So it's just going to go round and round on this output here, and then it comes back. If no buttons are pressed, it comes back all the way up and starts again. Now as soon as so you can see the outputs pulse. This is really slow motion. 1 2 3 4, 1 2 3 4. As soon as I press one of the buttons, let's just say, I'm not even sure which one this is. There you go. It was when Q0 was pressed and I pressed D1, that was number 5, and therefore it knows. It sets a variable, A is 5, and it prints it out on the LCD there. Let's try this one. Okay, now that one obviously might be easier to understand if we watch it here. If we press play, nothing. It's not going to be that obvious unless we view the digital output. So you can see these are cycling really quickly. Now as soon as I press this one, it's only going to agree on the output that sends the output to this row here, and it's a checking for that input there on that one there. So I'll press it there, and you can see as I hold it down, output 2 When output 2 is high and input 1 becomes attached, then we know it's 6. If I do, it's columns. If I do output 2 and input 0 is pressed, then we know it's 3. Okay, so there's that grid. It'll pulse through them constantly. So 9, output 2, and input 2. That's when that's pressed. And then B, in this case, I've labelled them to be star hash, like a telephone keypad. And actually, on our real thing, A, B, C, D, go A, B, C, D. It's the other way around. So that says A, that says B, that says C, and that says D. Okay, so just so you know, let's have a look at the flowchart here. We can only set a numerical variable on this A. I can't say this is star, for example, or this is D, whichever one it is further down the line. So we've got 1 to 9, quite simply, and 0, in fact. 0's quite easy. But 10, 11, 12, 13, 14 and 15 basically go for a check. So if A is 10, we just hardwire it to say star. If A is 11, we hardwire it to say hash A, B, C, D, etc, etc. And then down here, if it's none of these, then it's just going to be a normal number 0 to 9, and that is basically variable A plotted on the LCD. I've given it a little pause. Let's just take the pause out and see what happens. So when we press play, I haven't even tried this yet. That's what happens. So it just gives it enough time to keep that character displayed on the LCD screen. So yeah, you do want the pause there just to make sure it just stays there for half a second. Enough time to be able to, it's quick enough not to kind of make the keypad too slow to enter numbers, but fast enough to you know, stay there, slow enough to stay there and be able to read it. So let's say, I mean, on this thing we've got hash star A, B, C, D, but that could be custom printed with your own thing. So that could be enter, delete, up, down, whatever. So you might, instead of having this here, if A equals 10, instead of this one here, A equals 10, we could have just a subroutine here saying go to the enter part of the command if you want. So yeah, that is a very simple but quite big part of it. Now bearing in mind we could actually make it a bigger one. There's no harm actually going off the page. If I were to, it's going to take a long time to do it, so I'm not going to do it all, or if I do I'll speed it up. But let's just delete that. Now we'll just take that, so let's just say, let's put the next one along like that, see what happens. Now this time I'm going to assign a new variable, and like I say, it's going to take quite a while, so maybe I'll just cut and paste it. Sorry, I'll stop the video and restart it in a second, having changed these all to B and rewired it. So as you can see, it's taken me a little while to copy and paste these. Now each column I've changed A to B to C. So it's recording 3 sets of variables, A, B and C, 3 digits. Now instead of the A, B, C, D buttons, I've said these two, obviously A and B, they can be enter, and C and D can be exit. So I've done a little subroutine saying enter and exit. Now if you follow it round, we've got the note, what we saw last time. So each time you press a button, first of all A is recorded and it's plotted on this thing here, A. Then the same thing happens, but when you press a button, B is recorded and then it is plotted there. And so on, and C is recorded. You could have 4, so you could have 4 columns here to record a pin number or something like that. Now this is kind of novice beginner's guide stuff anyway, so hopefully if you're going to do something as accurate as that and you need to store data, that you'll have to figure out yourself through the help section in that. But this is a nice interface to be able to record numbers, and then obviously enter the subroutine here is just that, and it will just bring it back to where it was called, which are these two bits here. Now these come back to the beginning. Technically you wouldn't even need that exit, because all that would do is just bring it back to the start. Now you might even want to wipe what is said on the LCD before doing that. We'll just show you what that might look like. So I'm going to just take that one, and hopefully I can just slap it in there, you know. There we go. And now I'm going to just put nothing there. Okay, now watch this. So nothing on the screen. I press a button, I get your first digit stored in variable A, then B, and then C. Now give it a little bit of time because I had a 2-second wait, and then there's that blank screen. So 4, 5, so 4, 5, 6. Now being a simulation, you have to it's not as instantaneous. So 7, 5, 3. Okay, and then 2 seconds it goes. What about 4, 5? Oh, I don't like that. Okay, so I think that's enter. These two are enter, and then 9, 5, exit. That's it. There you go.